Introduction. Nitrogen, N, is a key nutrient in river systems. Its concentration and form in the aquatic environment generally reflect the integration of a number of sources within the catchment, including point and or non-point sources. In addition to these anthropogenic contributions, there are natural contributions from the mineralisation and nitrification of organic nitrogen in soils. Within aquatic environments, nitrate, NO3, is generally the dominant infraction due to high NO3 mobility in the environment, as a result of its persistence, high solubility and low reactivity. The N problem, due to the excessive application of fertilisers for crop production, has been of growing concern in recent decades as it affects the water quality for consumption, promotes the development of eutrophication and reduces biodiversity. Changes in the climatic conditions and, particularly, increases in air temperature, shifts in rainfall patterns and an increase in the frequency of flood and droughts alter the processes controlling the mobilization and transfer of N from agricultural land to aquatic ecosystems. Rising water temperatures influence biological processes and chemical characteristics of water resources, for example increasing the mineralization of organic matter, decreasing oxygen solubility, increasing the variability in pH values and increasing growth rates of aquatic organisms. A lower water availability might affect the quality of surface water resources adversely and even have a significant negative impact on human health and the economic development of the entire region. Since protecting and restoring the aquatic ecosystem is a policy priority in Europe, catchment management planning should focus on adaptively managing climate change impacts, although climate change is not explicitly included in the European Water Framework Directive, WFD. Because climate change is expected to have profound effects on water resources and water quality. The facts show that effects of climate change have not been properly addressed in policy formulation and water resource management strategies in many regions around the world, probably due to the lack of accurate and reliable data on the possible effects of climate change on water resources. Nitrogen pollution is already considered as a global problem, and it is expected that N loss will aggravate in vulnerable areas due to climate change. For this, it is of utmost importance to assess and quantify the impacts of climate change and vulnerability of water resources and evaluate the efficiency of possible adaptation and mitigation policies. While many researches in different study areas assess the climate change impacts on catchment hydrology and water supply, water quality has been studied much less. So, little is known about the potential effects of climate change on biogeochemical processes at catchment scale and its associated impacts on water quality. So far, very few studies have addressed the water resource on the Atlantic region of Europe, and, consequently, little is known about the effects of climate change in water quality in this area. This can constitute a challenge because hydrological processes in this region will change in response to climate change, as they are expected to undergo a Mediterraneization process. In fact, in the northwest of Iberian Peninsula, an increase in temperatures, 2 to 3 degrees Celsius, is expected, particularly during spring and summer, with marked uneven distribution of rainfall, i.e. more rain in autumn but drier spring and summer. Likewise, according to the Intergovernmental Panel on Climate Change will cause an increase in the future winter storm and flooding for the Atlantic region of Europe, which encompasses northern Iberian Peninsula, western France, the Netherlands, Belgium, northern part of Germany, western Denmark and the United Kingdom. Uncertainties involved in climate predictions are larger in this transition zone of the Atlantic region than in other areas, for example the northern and the southern parts of the continent. Therefore, this transition zone should be an in-depth studied area. This paper provides an overview of the effects of changes in climate on nitrate loads in NW Spain. Specifically, the main objective of this study was to assess the impacts of the potential changes in climate variables, temperature, rainfall and CO2 concentration, on nitrate load in an Atlantic agro-forested headwater catchment located in NW Spain using the SWOT model, one of the most widely used catchment models throughout the world, in order to provide information to catchment management so that they can anticipate possibly the impact on water quality and design and implement the necessary mitigation actions within the catchment management programs.